This video is about absolute value inequalities. Absolute value is a term used to indicate the distance of a point or number from a 0 point of a number line. Here are some facts about absolute value. Since absolute value is about the distance, therefore, absolute value is non-negative, which means absolute value greater than or equal to 0. For example, absolute value of negative 2 equals 2. Absolute value of 2 equals 2. Then from these two, we know the absolute value of x equals absolute value is opposite. In other words, I can write down absolute value of ax minus b equals absolute value of negative ax plus b. Or I can write down absolute value of a minus b equals absolute value of b minus a. Look at the graph of y equals absolute value of x. From this graph, you could say this is y equals x when x greater than or equal to 0. This part is y equals negative x when x less than 0. According to this graph, we can write down absolute value of x equals negative x when x is negative. When x greater than or equal to 0, you will get x. For example, let's still using the absolute value of negative 2. Since this is a negative number, we will get its opposite. Negative 2 is 2. Absolute value of 2, since 2 is a positive, so we will get itself, that's 2. This formula can be used to change absolute value function into piecewise function. For example, y equals absolute value of x minus 4. First of all, we will figure out x minus 4 equals 0. Then x equals 4. Then we have when x greater than or equal to 4, you will get itself x minus 4. When x less than 4, you will get the opposite of x minus 4, that is negative x plus 4. In this way, we change this absolute value function into piecewise function. For number 2, y equals absolute value of negative 3x plus 6. First of all, when you change absolute value function into piecewise function, make sure y equals absolute value of ax plus b. This a is a positive, so that it will be increasing function. It's easier for us to write down those two functions. Since the coefficient of x is negative, opposite of negative 3x plus 6 will be 3x minus 6. Then we work this out. 3x minus 6 equals 0. X equals 2. When x greater than or equal to 2, we will get itself, that is 3x minus 6, because this is an increasing function. When x less than 2, we will get its opposite, that is negative 3x plus 6. Let's figure out the absolute value inequality rules. For absolute value of x greater than or equal to a is greater than or equal to 0. Think about this is a y1 is a absolute value of x, and a y2 equals a. So we get this graph. This part of our graph is y equals x. This part is y equals negative x. Then the x coordinate for these two intersections is negative a and a. Let me label here negative a and a. Absolute value of x greater than or equal to a, which means part of the graph above y equals a will be the solution. The domain will be this and this. This is a negative infinity. Here is a positive infinity. So we can write down negative infinity to negative a bracket union with the positive a to positive infinity. Or we can write down inequality, that is x less than or equal to negative a, or x greater than or equal to a. This is the solution to this absolute value inequalities. For absolute value of x less than or equal to a greater than or equal to 0. We know this line is y equals a for x coordinate. This is negative a, this is a. Then absolute value of x less than or equal to a, which means part of a graph below y equals a will be the solution, which means from here to here. We can write down the inequality x greater than or equal to negative a and less than or equal to a. Or I can write down interval notation. Close the interval from negative a to a. This will be the solution to this absolute value inequalities. Let's go over the rule for absolute value inequalities. When absolute value of x greater than or equal to a, the solution will be x greater than equal to a or x less than or equal to negative a. When absolute value of x less than or equal to a, x greater than or equal to negative a and less than or equal to a will be the solution. Using absolute value inequality rules, let's figure out for number 1. Absolute value of 2x minus 6 less than 1. Let's draw a graph. This is a negative 1. This is a positive 1. This line is y equals 1. Absolute value of 2x minus 6 less than 1, which means the part of the graph below y equals 1 will be the solution. So from here to here, we will set up the inequality as 2x minus 6 greater than -1 less than +1. Then solve this compound inequality. Add 6. So we have -1 plus 6 less than 2x less than 1 plus 6. So we have 2x greater than 5 and less than 7 divided by 2. For every single term for these inequalities, we have x greater than 5 over 2 and less than 7 over 2. Since we divided by +2, the symbol will stay the same. For number 2, coefficient of x is a negative. Let's change into positive because absolute value of negative x equals absolute value of x. So we have 5x minus 7 greater than or equal to 4. When we change the coefficient of x into positive, when we solve inequalities, we don't worry about a symbol because it will stay the same. Let's draw this graph. We have this is -4, 4. This line is y equals 4. Absolute value of 5x minus 7 greater than or equal to 4, which means part of the graph above y equals 4 will be the solution. So here, this is the domain. We will write down 5x minus 7 less than or equal to -4, or 5x minus 7 greater than or equal to 4. We will solve these two inequalities separately. Add 7 both sides. You have 5x less than or equal to 3 divided by 5. So x less than or equal to 3 over 5. For this one, add 7 both sides. We have 5x greater than or equal to 11 divided by 5. X greater than or equal to 11 over 5. This is all. This will be the solution to this absolute value inequalities. For number 3, first step, you need to isolate the absolute value. Therefore, add 6 both sides. You will have -4 absolute value. We will get this opposite, that is 2x plus 5 less than -4. Then we divide by -4 both sides. You will get absolute value of 2x plus 5 greater than 1 because we divided by -4 both sides. Remember, mommy, daddy, nanny, when you divide by negative number, you need to switch the symbol. Then we need to draw this graph. This is y equals 1. The x coordinate here is -1, 1. Greater than 1, which means part of a graph above y equals 1 will be the solution. So this part and this part. We will write down 2x plus 5 greater than 1, or 2x plus 5 less than -1. Solve. Minus 5 both sides. You have 2x greater than -4. then divided by 2. Since we divided by a positive number, we don't worry about the symbol, because symbol will stay x greater than -2. Minus 5 both sides, you have 2x less than -6. Then we divide it by 2. You will get x less than -3. Use OR. This will be the solution. Let's go to number 4. Isolate the absolute value on one side, so we add to both sides. We have 3 absolute value, x minus 6. We try to get the slope of this function. We try to make opposite of negative x plus 6 so that the coefficient of x is a positive, then less than or equal to 9. Divided by 3 both sides. Since 3 is positive, symbol will stay. You have absolute value of x minus 6 less than or equal to 3. Let's draw the graph. This is y equals 3. The x coordinate is -3, 3. Absolute value less than or equal to 3, which means part of a graph below y equals 3 will be the solution. So this will be the solution. The domain will be between -3 and 3. Therefore, we can write down x minus 6 greater than or equal to -3 and less than or equal to +3. Then we add 6. Both sides, you will get -3 plus 6 less than or equal to x less than or equal to 3 plus 6. So we get x greater than or equal to 3 and less than or equal to 9. This is the solution.